Hello and welcome. What's up YouTube? This is me and this is a new tutorial on brick breaker. Okay, so previously we have developed our basic interface, okay, and then we have developed our custom ball, our custom pad, and then our custom brick. Okay, so in this tutorial we will actually add a motion to this ball. Okay, so let's begin the lecture. So first of all, for creating a motion to our ball, okay, so we need a function. Okay, and why we need a function? The reason is that we need to call that function after certain time period. Okay, so in many games you have observed that they are running at 30 frames per second or 60 frames per second. So what does it mean? It means that they are actually calling a certain function 30 times per second. Okay, so similarly we will use the same phenomena here. Okay, so first of all, let's create a function that we will call after a certain time period. Okay, so for example, I will name it like motion or small m. Okay, motion, motion underscore ball. Okay, so this will be the motion of our ball, and for now I will print something like motion. Okay, motion, motion. Okay, so we need to call this function after certain amount of time. Okay, so it's very simple. First of all, we need to call here init function. Okay, init, and you know very well why we are calling here init function, because now we will actually do some Python programming. So that's why we are calling here init function, and then this star kwargs are required for the internal working of Kivy. Okay, so that's why we are passing here star kwargs, and now we need to call a super function here, and with the help of this super function we will call the init function of this widget. Okay, so just type here init dash init. Okay, and also pass star kwargs here. Okay, and now inside this init function we will create such a logic that will call our this function after certain time period. Okay, and for this purpose I will use clock. Okay, so what is clock? So clock is basically a class, okay, which allows us to call a certain function after several interval of time. So we will import this clock, and it is from kivy.clock.clock. Okay, so, and now we will call a function of this clock, and this is schedule interval. Okay, so we need to schedule interval, and inside this schedule interval we will pass callback. So callback basically is our function, and we need to define our timeout. So timeout basically represent the interval of time after which we will call this function. Okay, so just write SCHE schedule interval, and here we will pass this motion ball. So just write here self dot motion motion ball. Okay, and now we need to actually define our time period after which we will call this function continuously. Okay, so for example, let's suppose for now I will go with like 0.1. so after every 0.1 second we will call this function. Okay, so I hope this will work fine. So if I run it, you will see that it will print motion. Okay, so we got an error, and that is okay. So here in motion ball, actually this is related to our time period, okay, our clock. So that's why along with self we will pass here dt. So dt basically represents delta time. Okay, and now it will work fine, and you will observe, yeah, motion, and it is continuously printing. You can see that this bar is becoming smaller and smaller and smaller. Okay, now inside this motion ball we will actually pass this ball. Okay, so that we will change its x-axis and y-axis. So it's very easy. So first of all, let's create an ID for this ball. Okay, and I hope you know very well what what is id? So id basically represents our widget, okay, and yeah, we can actually access our widget in our main.py file, which is basically present in our Kivy design language file. Okay, so with the help of this ball id, we will access this wall in our main.py file. Okay, so it's cool. So first of all, we will get the x-axis and y-axis of our ball. So just write here x and y, okay, and I will call self.ids dot what is the name? Yeah, ball. Okay, ball dot position. Okay, so we will return the position of our this ball, and we will store that position in our x and y variable. Okay, and now we will actually move our this x and y position. Okay, so it's very easy. Just write x is equal to x plus dp of 10. Okay, I want a transition of 10, and we need to import dp as well. Okay, so just import dp, and I will do the same process for y as well, y plus dp of 10. Okay, so it's cool, dp of 10, and now we need to assign this x and y variable to the position of this ball. Okay, so just write here again self.ids.ball.position is equals to it will be a tuple. Okay, so make sure that you put here rounded brackets, okay, otherwise it will not work. So x and y. Okay, and I hope this thing will work fine and our ball will move. Yes, it is moving, so it's cool. Okay, and now you have observed that our ball is not on the screen. Okay, so we actually need to write such a logic that whenever our ball hit the sides of our screen, it should bounce back. Okay, so let's create that logic. So first of all, I need to get the height and width of our screen. Okay, so with the help of this window.size, I will get the height and width of our screen, and I will store that height and width in our capital X and capital Y variable. Okay, so capital X, capital Y is equals to window window.siz. Okay, and now we will write here if condition, that if our X, which is basically the X position of our ball, if this is greater than our X, okay, so this capital X basically represents the width of our screen. Okay, so if X is greater than X, then I need to actually change this X. Okay, so instead of writing here dp, I will create a separate variable for the transition. Okay, so here let's define a global variable, and I will call it like x underscore velocity, okay, is equals to dp of 10. Okay, and here I will define y underscore velocity, and I will go with the dp of 10 here as well. So it's cool. And now instead of writing here dp, I will call the two variables, so self dot x underscore velocity. And now you are thinking that why I am writing here self. So this is because this x underscore velocity is not a variable of this function, instead it's a variable of this class, and to access the variable of a class we write here self. Okay, so that's why I'm writing here self dot x velocity, and I will do the same process for the y as well. Okay, so just write here self dot y underscore velocity. Okay, and now we will actually change the sign of this x velocity. Okay, so just write here x underscore, not x, self dot x underscore velocity is equals to negative of self dot x underscore velocity. Okay, so if our velocity is positive, this condition will make it negative, and if it is negative, this condition will make it positive, and this is how our ball will bounce. Okay, and if our this x is less than equals to 0, so instead of just greater than, I will put is equals to as well. Okay, so if our x is less than or equals to 0, then I need to change the velocity as well. Okay, so just copy it, paste it here. Okay, and now I need to define condition for my y as well. Okay, so if y is greater than or equals to width or height of our screen, okay, and then I need to change the y-axis, the y velocity. Okay, so self dot y underscore velocity is equals to negative of self dot y underscore velocity. Okay, so it's cool. And now I need to define my fourth condition. Okay, and I will write here y, if y is less than equals to 0, okay, then I need to change the y velocity as well. Okay, so just copy it and paste it here, and hope this thing will work fine. And instead of updating my position here, okay, I will update my position in the end. Okay, so just copy these 3 lines, just cut it, okay, and paste it here. Okay, so paste it here, and now I hope everything will work fine. And it is working fine. And okay, so it is actually bouncing, but you have noticed that it is actually moving outside of the screen and then it is bouncing. And the reason is that the coordinate system in this Kivy library starts from bottom left corner. Okay, and we need to actually subtract the height and width of our this ellipse. Okay, so just subtract from here the dp of the width of our ball, and in this condition the width of our ball is 50, so just subtract here 50 as well. Okay, and for y I will subtract here dp of 50 as well, and now this thing will work fine. Yes, everything is working fine, it's cool. Okay, so this is how our ball will bounce. Okay, so everything is working fine. So I hope you have enjoyed this tutorial, and in the next tutorial we will add motion to this pad. So till that point, bye bye.